Hello everyone, welcome back to my channel, and in this particular video we are gonna learn about LoRa or long range. So what exactly is LoRa and why is it so famous in the world of IoT? Well, the second point we'll address at a later point of time, but what exactly is LoRa? Well, LoRa is, in simple terms, it's just a pure modulation technique. It's nothing else. It's a modulation technique that has been patented by a company called Semtech, and then on top of that some other non-profit organization had developed the software stack, and that's how it came into existence and is so famous now. So LoRa is simply, it's a modulation technique. It's based on what we will see it soon. But before that, what exactly is modulation? Well, modulation is a technique in which you encode the information that you want to send. That is the information signal. You encode the information signal with the carrier signal, which will carry the information, and it gets transmitted. So modulation is just a technique to encode information into a carrier signal, and then on the receiver side what you get is a demodulator or demodulation techniques is applied, in which the information signal is extracted from the carrier signal. So these are the some basic examples of modulation. For analog signals we have amplitude modulation and frequency modulation, commonly known as AM and FM, as you guys might be already be knowing it. And for digital signals we have the shift keying techniques for frequency, amplitude and phase. So for digital signals there are many more techniques that are available to us, but at the very core or base level we have these three techniques that are used. In the picture that you can see on the screen, it's a form of AM or amplitude modulation. The blue color waves are the carrier waves, while the red color signal, the red color line, is the information signal. So you can see how the amplitude of the carrier wave gets adjusted to the amplitude of the information wave. It's just a way of modulating using amplitude modulation. So what does LoRa use for modulation? Well, LoRa is actually based on something known as CSS, or chirp spread spectrum, not that CSS what we use in HTML. It's a different CSS in communication. Well, CSS stands for chirp spread spectrum. So what is this thing CSS? Well, in CSS you have up chirps and down chirps. So what happens is that if you want to transmit let's say high, that is digital 1, then you start from low frequency, let's say X, and then it gets increased over a certain time period to Y, which is a higher frequency. So X to Y shifting, that is from a low frequency to a high frequency over a period of time, is known as up chirp, while the reverse is known as down chirp. That is from high frequency to low frequency, it's called down chirp. So a combination of these up chirps and down chirps constitutes a signal, and LoRa or long range is actually based on this CSS or chirp spread spectrum. So it's a form of spread spectrum modulation. We are not going to deal with the spread spectrum modulation in this particular video, but just for the understanding, you can say that it's based on CSS, which stands for chirp spread spectrum. But the point that you have to keep in mind is that the frequency of LoRa differs from different areas. Why? Well, LoRa is based on LoRa is actually deployed on the unlicensed bands, or the ISM band, which stands for industrial, scientific and medical, ISM bands. And ISM bands are different for different countries. So for India it's 865 to 867 megahertz. For South Korea it's 920 to 923 megahertz, and that's the band where where LoRa gets deployed. So if you are developing a LoRa solution for India, it may not work in the United States or in Europe. So you have to be very specific as in what where you are actually deploying LoRa, and based on that your hardware should be designed. So ultimately, everything boils down to the fact that why even LoRa is used when there are, like for US you need one piece of hardware, for Europe you need another piece of hardware. Well, why is it even used? Well, the simple reason is when you're dealing with IoT, you always look for like a couple of parameters. One is the device should consume a lot of low power such that the battery life can be extended up to a couple of years at least. The second thing is secured communication, and the third that we look for while building a IoT network or IoT solution is how much long range I can go up to. So all these three things are like supported by LoRa. So LoRa supports low power, it supports secured communication, it's encrypted, it supports, and it is obvious long range as the name suggests. And this important thing that we will see in a few moments, that it's like you can actually form your own private network using LoRa, and that's why LoRa is so popular. So let's imagine that you have an agricultural field of some hectares, and every 10 meters or so you have installed some sensors, let's say temperature, humidity sensors on in the soil, like embedded in the soil. Now obviously we are not gonna send data using GSM that is based on the 4G or 5G spectrum. We're not gonna do that because of the simple reason that these devices which are based on the GSM network, simply it consumes a lot of power. So probably battery will be out within a day or two at the most. So low power is obviously the first thing that we require in this kind of situation, and LoRa is a perfect candidate for it. There are many more ways in which you can actually do the same thing, like narrowband IoT or Cat-M1 or LTE-M, but we're not going to discuss that here. So what happens is that all these LoRa nodes that are embedded in the field, or sensors that are embedded in the field, they are communicating with the LoRa gateway. So LoRa nodes all communicates with the LoRa gateway, and LoRa gateway communicates with us. So the components of LoRa is basically it's a LoRa node and a LoRa gateway. And how it is deployed, you have lots of LoRa nodes, as I mentioned. In case of an agriculture farm, you have all these sensors which are LoRa nodes, the LoRa endpoints. Now they are communicating with the LoRa gateway. And what the LoRa gateway does, it decodes all the signal that's being transmitted from the LoRa nodes, and the LoRa gateway simply pushes that signal to any of the platform. Now this can be done using REST API calls or over WebSockets, like something like MQTT or TCP/IP. It can be done anything. So what you have to take care is you have to program or configure the LoRa gateway to decode the messages that are coming from the LoRa nodes and what to do with those data. So that's the main important part in the concept of LoRa deployment, the demo that I have put up for you guys to see. So what we have done is that we have two devices or two LoRa nodes or two LoRa endpoints, and one of this particular device that you can see contains a GPS sensor. We are not going to use it for now. What we are going to do is like simply use this device to send the information D1 and use this device to send the information D2. Now these two are connected to my LoRa gateway, which is a Dragino LG01N series gateway. The link of the gateway is pasted in the description. So what my LoRa node does is that it sends D1 from one device and D2 from the other device using LoRa RF or LoRa modulated signal to a LoRa gateway. Now my LoRa gateway decodes those signals and then it transmits that to a MQTT broker. Basically it publishes the signals to a MQTT broker in a particular topic, and that's what you can see in the screen. You have D1 which is coming from the device 1, and then you have D2 which is coming from the device D2, and that's how the entire thing is operating. I'm publishing all those data to this particular topic, hello/LoRa/Avido, which I have configured in the Dragino gateway configuration portal, and from the gateway the messages are being published to the LoRa, to the MQTT broker. There's a simple demo that can be achieved using LoRa. So this is all about LoRa a long range, and I hope I was able to cover the introductory aspects of long range, the LoRa modulation technique in this video. So LoRa is mostly deployed in areas where there is a cluster of devices. Not like that you have one device and you need to use LoRa. That's not recommended. In those cases, we are gonna use something like narrowband IoT or some form of cellular connectivity. LoRa is mainly used, let's say you have a cluster of around 100,000 or any number of devices, especially mostly more than like, there should be at least some devices to connect to. Let's say these devices are spread across like a radius of around 10 kilometers or 20 kilometers or something like 50 kilometers. In those cases, you can have one LoRa outdoor gateway which will be connecting to all of your LoRa nodes, and then the message that are coming from the LoRa nodes will be pushed forwarded to the IoT platform using the LoRa gateway. Now there are two kinds of LoRa gateways that are available. One is an indoor gateway and the other is an outdoor gateway. The one that I've showed you in this video is an indoor gateway, while there are specific outdoor gateways which are very powerful and it has a long range. The one that I'm using has a range of like up to 1 or 2 kilometers at the most, line of sight communication. But if you're using an outdoor gateway, you can get way too much range. Possibly line of sight communication or non-line of sight is also possible. LoRa is, the range will specifically get reduced if you are deploying it in an urban environment because of the presence of buildings and concrete walls. But if you're deploying it in a rural environment, then there is possibility, not much chance of the range getting reduced if you're using a high powered LoRa outdoor gateway. So in the next video, what I'm gonna show you is probably how I have programmed my Arduino device to send those messages and what library I have used. It will be a short video just for the programming part. I might also show you how I have configured the gateway, but you know what, like the gateway configuration differs from manufacturer to manufacturer. So, and also they keep on releasing new patches. So by the time you might be seeing this video, the newer patch has already come and it has already changed. It happened to me. I followed a video on YouTube to figure out the configuration portal, and when I was opening on my side, I found that nothing is matching. So I had to email to a developer and get the details or to get the specification of the device and how to use the configuration portal, and after that I was able to do the configuration. So I'll be concentrating in the next video mostly on the hardware side of it, and I hope you found this video interesting. Please like, share and subscribe to my channel to get more technical content as well as non-technical content, as I've already seen in my previous video. I will probably meet you soon in the next video. Thank you and meet you soon.